Hello, I'm Callie and today I will be discussing kinematic equations. So first, what are kinematic equations? Well, kinematic means the properties of an object or system in motion. So kinematic equations are equations that are used to describe and represent the motion of objects. So these equations can be used for objects that are moving at a constant velocity, which means that they have an acceleration of 0 meters per second squared, or a constant acceleration. So they cannot be used during a time period when the acceleration is changing. So now there are four kinematic equations, but before we look at the equations, let's look at the four variables that are used in the equations. So the first variable we look at is delta t, which is time or change in time. A, which is acceleration. Delta x equals displacement, or is also known as the change in distance. And lastly, we have v, which equals velocity, and it's broken down into vi and vf, which is initial and final velocity. So in the actual kinematic equations, you will never see just v. It's always broken down into vi or vf. So I mean, technically you will see 5 variables within the equations, but vi and vf are parts of the whole velocity, so we consider it as just 4 variables. So now we're going to take a look at the kinematic equations. As I said, there are 4 of them, and here they are. So basically what you do with a kinematic equation is, usually in the question, you're given 3 variables that you know, and then you can solve for the 4th. And also in real life examples, this is why it's useful, because you can make predictions about an object's motion if other information is known. So if you're given a question, or if you're out in the real world and you have 3 of these variables, then you can solve for the 4th. So what you do to find the right equation to use is you find the 3 variables that you have, and you find the 4th that you want to know, and then you look through these 4 equations and you find the equation that has all 4 of those variables that you want to use, and that is the equation that you will use to solve for that unknown variable. So now I will just give you a second to look at these equations and to just kind of understand how they're used, what they look like, just so you can get comfortable with them. Okay, if you want to look at them for more time, you can just pause the video here, but for right now I'm going to just X out of this for a minute. And let's look at some basic examples, but before I really go into the basic examples, I want to go over the method that I use for solving equations. It's called the GUESS method, so G-U-E-S-S, and I recommend this for these type of equations, or for these type of problems. So G, your givens, U is your unknown, E is your equation, first S is to substitute, and the second S is to solve. So if you just go through this process in that order, these questions are usually not that difficult, and they'll just become like secondhand nature to you. So let's look at some basic problems, and I'm not going to put them in like a written out problem just yet. We're just going to go through some basic steps so that you understand how these equations are used, and then once I go into the real world examples, I'll give you like a full problem, and you'll have to take out the givens and the unknowns from it. So just for now, I'm just going to give you the givens like this. So you're given that VI equals 10 meters per second, given that A equals 5 meters per second squared, and you're given that delta T equals 30 seconds. And your unknown, that what you want to solve for, is delta x. So what equation are we going to use? Let's take a look. So we need VI, we need A, we need T, and we also need delta x. So why don't you pause for a second right here and try to find what equation has it. Okay, so the correct equation would be equation number 2. It has all 4 of the variables that we want to use, and so yeah, so equation would be number 2. And then we substitute. And so if we look at number 2, it's delta x equals vi, change in t, plus 1/2 a t squared. And then you substitute this all in. So we're solving for delta x equals 10 times 30 plus 1/2 times 5 times 30 squared. And then to solve, again, just pause the video and try to plug this into your calculator to see if you get the same answer that I got. So when you solve, delta x should equal 2,550 meters, 2,550 meters should be the change in distance that you get for this problem. And so yeah, really all you do is just plug this part here into your calculator, and that's what you should get for delta x. This is one of the simpler ones where the delta x is on the equals side by itself, so you don't really have to do any dividing or anything. It's just simple multiplication. But it's a good one to start out with just so you can understand how it works. So let's take a look at another easy one like this. My bad. So again, I'm just going to give it to you in the same format. So your givens are vi equals 20 meters per second, a equals 3.3 meters per second squared, and your delta x equals 130 meters, and your unknown is VF. Equation. Why don't you pause the video again quickly and look at these equations and figure out which one you need to use. Okay. So the correct equation that you would want to use is equation number 3. It has all 4 of the variables that we're looking for. So now we substitute. So number 3, so VF squared, what we're solving for, minus VI squared equals 2A delta X. Let's plug this in. VF squared, so what we're solving for, minus 20 squared equals 2 times 3.3 times 130. So what you want to do here is you want to plug this part into your calculator and get what 20 squared is, and you want to add 20 squared to this, whatever you get, and then you're going to want to find the square root of that answer, and that should get you VF. So why don't you try that on your calculator so that you can get some more practice, and pause the video, and then I will reveal what the correct answer would be. Okay, so if you did that correctly, you should get that the VF equals 35.5 meters per second. And so that does make sense. I mean, if you're accelerating at 3.3 meters per second squared and you're traveling 130 meters over time, just over that distance, your velocity should pick up a solid amount, and 15.5 meters per second is a solid increase. So now we're going to take a look at some written out problems where I'm not just giving you the givens and unknown. You have to look at the problem and actually pick those out for yourself. So I'm going to give you the problem, and I would suggest that you pause the video, read it, and try to find the givens, the unknown, and try to solve the whole equation. Try to solve everything by yourself before I go over it. So yeah, here is the first question, and again, pause the video here before I go over everything. Alright, so question 1. Tom is driving his car at 20 meters per second. He sees a stop sign and travels 23 meters while making a stop. How long did it take Tom to stop his car? So, let's go over everything. So the givens in this equation that we have, the the givens in this problem. So if you read the question and you understand it, so he's starting at 20 meters per second. And it doesn't explicitly say what his final velocity is, but if somebody is coming to a stop, that means that their vehicle is not moving. So VF would equal 0 meters per second, and your change in distance or displacement would be 23 meters. So your unknown, what we were supposed to solve for, would be change in time or time. So the equation that we want to use for this, let's look at the equations real quick again. If you look at equation number 4, it has all 4 of the variables that we are looking for. So we will be using equation number 4. Substitute. Sorry, my handwriting is atrocious. So equation number 4 is delta x equals vi plus vf divided by 2 times change in time. So basically for this one, since we're solving for delta t, what you want to do is plug, here, let me do this. So 23 equals 20 plus 0 divided by 2 times change in time. So what you want to do is plug this into your calculator and then divide 23 by this, because if you divide by this, you'll get delta t by yourself. So when you solve all of that, don't want solve written, we want solution. Solve. When you do all of that, you should get that delta t equals 2.3 seconds, which does make sense, because he went from 20 to 0, only traveling 23 meters, so that means that he made a quick stop. He must have been going a little bit too fast and had to stop really quickly. So let's look at one more real-world example to wrap this up, and we'll use this question right here. So again, I would pause the video before I go over everything. So yeah, pause the video right now, and then I will go over everything after. Okay, so Annie is running at 4.7 meters per second. She speeds up to 6 meters per second in 44 seconds. What is her acceleration? So let's look at our givens. So we are given in the problem that initial velocity is 4.7 meters per second, and that VF is 6 meters per second, and that delta t equals 44 seconds. Our unknown, what we're trying to solve for, is A, acceleration. So not substitute, we gotta find the equation first. So what equation do we have to use? If we look for the right equation, we are looking for equation number 1, which has all 4 variables that we are looking for. So number 1, and let's substitute all this in. Okay, so equation number 1 is VF equals VI plus A delta T, and 6 equals 4.7 plus A times 44. So what I would do is subtract 4.7 on each side and then divide by 44 so that you could get A. And when you solve, if you do it correctly, you should get that A equals 0.03 meters per second squared. So that is the last problem I'm going to do with you. I hope you enjoyed this video, and yeah, so thanks for watching, and I hope that this video helped you understand what the kinematic equations are, how to use them, and how they can be used in real-world situations. Again, thank you for watching. Have a good day.